Oops. Oh, I gotta put the card in there. Apparently, I rescheduled the stream and only half rescheduled the stream. I put it into the title, but I didn't actually change the date in the YouTube event. And so a bunch of people showed up and they were like, what's going on? Yeah, sorry about that. And then I didn't see any references to it until I opened up the live stream now, and I can see the big conversation that was happening from everybody. So, yeah, I apologize. I hope everybody had a wonderful holiday. I didn't do anything, so it was wonderful. And we're kind of now getting back rolling. Things are picking up again. Still pretty quiet though. So, getting a lot of gaming done. Both Path of Exile 2 and Project Zomboid both released big beta versions of their games. And so I've been doing that, hanging out with my kids, hanging out with my wife, reading, watching a lot of TV, movies. So it's been pretty good, but it's nice to be back. And, you know, we've got lots of big plans for 2024. So 25. It's good. I got like 3 months, right? Where I remember it's going to be like getting the years mixed up. Yeah. So, for those of you who are wondering what it is that you have stumbled into, this is the weekly question show where you go ahead and give me any questions that you have about space and or astronomy and or, you know, dad philosophy. And I'm happy to provide it here. Now, for those of you who have never done this before, just a few ground rules. But go ahead and put any questions that you have into the YouTube comments. And I see that John Seffel is here. He is paired up with his AI overlord, who will also be gathering questions from the YouTube comments if he gets too tired. So hopefully we'll be able to get all the questions, put them into a database that I'm going to then be able to pull from and answer. And it feels weird watching it one time. I know. I review all of my videos at like 3 times when I'm like checking the video edit, or I'll watch my stuff at 2 times if I'm like really trying to be careful. And so whenever I watch myself at regular speed, I feel like I talk so slowly. And in fact, I watch everything at double speed, and it's not so bad, but for myself, it's unwatchable now because I just like, why don't I talk so quickly like I do in that show? So anyway, this is regular speed Fraser. I could speak twice as fast, but it wouldn't be that interesting, I think, and I'd make a lot more mistakes. So the ground rules. First rule is that I am a journalist, not a scientist. And so, if you're going to ask me questions about my opinions of scientific matters, I have none. I can only distill the combined knowledge, the scientific consensus, and give that to you as a, sort of jumbled up, compressed nugget of information. I try to give emphasis to the people who've never had their questions answered before. So whenever you ask questions and your questions make it all the way into the question show that we publish, we keep track of that. And so we try to spread the joy around to as many people as possible. And then the third thing is, often I will try to sort of keep a running tally in my brain of how often we've answered the exact same question. And we'll try to either put spins on it, or I may just avoid the question because I feel like we've answered that question so many times in recent memory that it doesn't make sense to sort of do it again. People are going like, oh, great, here comes Fraser's answer about whatever, about whether or not he thinks there's aliens in the universe. Bonsai fan, why not form an opinion based on the science or speculate for fun? I think it's really important to not do that. I think, I've gone on rants before, and you're about to trigger a rant. And that is like, like I think a lot of people, like a lot of the big problems that we see in science communication, in the arguments that people have online, the amount of denialism of various science and so on, comes from people listening to some charismatic communicator on some topic who tells you how to feel about dark matter, or the topology of planet Earth, or whether or not we went to the moon, or what's the best way to deal with vaccines, and so on and so forth, right? And it's because you've got one person who's doing a good job of communicating the information, but they're not being rigorous about pulling their knowledge from the scientific consensus. And really, only if you are capable of, of understanding the state of the art in that research and actually are doing work in that area, I don't think you're qualified to opine about, whether this theory is better than that theory, or whether, this is the right treatment method or that is the right, any of that, right? Like if you want to talk about viruses, then you need to be a virologist. Now, I can, as a science communicator, I can tell you what the scientific consensus is on virologists, or I can tell you what the scientific consensus is on climatologists, right? But I am not in a position. And I think it's, the longer that I do this, and the more that I watch people, and the more that I read comments on YouTube, and I see people doing that, it makes me really angry. And so I'm not going to do it myself. That's really my perspective. And so I now sort of really go out of my way to make that clear. Now, I get caught all the time, and there's a lot of things which aren't a scientific question or fall into my wheelhouse, science communication, things like that. And then I'm happy to opine about it because I feel like I have the required knowledge to be able to have that conversation. But I would much rather just have an open mind, maintain the scientific, just like literally just like, unless I have a better understanding of the science, the best thing to do is to just listen to the scientific consensus. All right. So let's get started. Okay. All right. Oh, we have new lighting. I am recording. Oh, I forgot to grab that. 1 second. Apologies. Sorry, I'm grabbing. I've got one story that's prepared. Or not. That should be assigned. Okay, all right, here we go. Ali H. Said, what do you think would happen if we figured out how life first formed? How would it affect the search for life elsewhere in the universe? So obviously right now, in the end of 2024, early 2025, the only concrete evidence that we have of life in the universe is here on planet Earth. Now, on planet Earth, life has found its way into every single nook and cranny. Wherever life can exist, it does exist, with a few interesting exceptions. There's some places where life could exist, but it doesn't exist, like on fresh lava flows, things like that, which is a story that we're working on Universe Today. It's really interesting. But anyway, so we don't know of any life anywhere else. We don't know of any life on Mars. We don't know of life on Europa and Enceladus. We have not detected any biosignatures in exoplanets with our big telescopes. But the hunt is on. Astronomers are looking through their telescopes at other planets, SETI researchers are listening for signals coming from other advanced civilizations. There are missions on Mars right now that are looking for past evidence of life. There's a mission going to Europa, multiple missions going to the Jupiter system that's going to be looking for life. And so what if we, but there's also a big question, obviously, about how life formed here on Earth. And the two processes, this idea of abiogenesis, right? How do you go from non-life to life? This question might get answered either here on planet Earth, or it might get answered by finding some evidence of life on another place. Because now you have this comparison. You can say, well, what were the raw ingredients that were available on Earth? What were the raw ingredients that were available on Mars? How could life have gotten going in one or the other of these circumstances? And so if we did figure out how life formed on Earth, how you got that process of abiogenesis, then that would give us an understanding of the kinds of places that we should be looking. It allows us to narrow our search, but it also kind of doesn't. Because even if we did find, we did figure out and scientists were able to reproduce abiogenesis in the lab. They're able to take a jumble of carbon molecules and water and hit it with electricity and then expose it to volcanic gases and then, right? And they were able to get some kind of first rudimentary life forming. Then the kinds of conditions that we have here on Earth, we kind of knew what conditions were available on Earth, whether it was, was it that it first formed down in the deep sea vents? That would be really interesting because that would tell us, okay, let's maybe search for places with deep sea vents like Europa or Enceladus. Did it form on the surface under a certain kind of atmosphere? Okay, maybe a place like Titan is a better place to be able to search. And then as we look out into the universe, we think about other worlds and go, okay, these are the worlds that have the kinds of atmospheres that match the kinds of conditions that life was able to form on Earth. So, it works both ways. That if we figure out how life first formed on Earth, then that tells us where to look out in the universe for other examples of life. If we find life in other places, then, in addition to Earth, then that gives us hints and clues about how life might have formed on Earth billions of years ago. So either way you go about it, it will be a revolutionary discovery if someone ever finds it. Rev and Miss J, what is a Lagrange point? See, so I'm guessing John avoided what is a Lagrange point, and the AI jumped on that question. Nathaniel Benjamin, my question, what are you most excited for in 2025? 3 guesses and the first 2 don't count. I am most excited for the Vera Rubin Observatory. And this is a telescope that is down in Chile, and it is going to be scanning the entire night sky every couple of nights from the southern hemisphere. And then astronomers are going to be downloading, I think it's like 20 terabyte. And then the telescope will be storing about 20 terabytes a day of data about the universe. And because it's coming back every few nights, anything new that has happened, any asteroid that has moved, any comet that's moved, any planet 9 that has moved through the field of view, any new supernovae, any other weird things that the universe is doing when we weren't looking have been recorded. And you'll be able to sort of do this comparison, say, here's what the night sky looked like 3 nights ago. Here's what the night sky looked like tonight. What's everything that changed in that time period? And astronomers have been looking in the sky for hundreds of years. And you think about these big catalogs, the Messier catalog. There are a lot fancier catalogs that have come out more recently with tens of thousands, even millions of objects. You think about the Sloan Digital Sky Survey and these other large surveys of the sky. And they're looking at the universe in the perspective of just space. Here's where all of the things are. But very little work is being done from the perspective of time. Here's how the universe is evolving and changing over time. There's a few things that do this. There's observatories that are looking for transient flashes, telescopes that have been looking for gamma ray bursts or fast radio bursts or various things that are kind of known that can happen in the sky. But with Vera Rubin, it is just this drift net that is just going to watch this huge chunk of the entire sky and try to highlight to astronomers anything that changed from night to night to night to night. And that's really exciting because it's going to be looking at the universe in an entirely new way, adding an entirely new dimension, time, in a way that we've never had before. And so I'm anticipating being really busy in 2025 because we're going to get the discovery of potentially hundreds of thousands of new asteroids. We're probably going to find Planet 9. We're going to find tons of new comets. We're going to find, like right now, astronomers know of like 3,000 Type 1a supernova. Vera Rubin's going to find 1 million of them. So it's just like anything that changes on a regular basis, Vera Rubin's going to find it. And then it's going to find a whole bunch of things that nobody asked for, nobody planned, nobody was expecting to see. Only those things that you can see when you're watching everything all the time. And I'm here for it. So that is absolutely the thing that I'm most excited for in 2025. Rev Keith Carter. If an exoplanet is tidally locked, it can't qualify as Earth 2.0, can it? It sort of depends on the situation. So, here on Earth, we are located 1 astronomical unit away, 150 million kilometers away from the sun. Our sun is a yellow dwarf star. The Earth has been around for 4.5 billion years. And that there are other planets in the solar system. And the Earth has a large moon that is sort of helps with its stability and potentially the formation of life on our planet. The Earth has a magnetosphere that protects it from radiation, both solar radiation as well as cosmic radiation. So what does Earth 2.0 mean? And obviously Earth 2.0 sort of tells you, like, it's the better version. Like, you've got Earth 1.0, that's the first release, but then Earth 2 comes out and it's better, stronger, faster. And of course it's not. I mean, the hope is that the second Earth, another Earth, will be an example of a planet that fits the same criteria as our planet, right down to the presence of life on that planet. And once you start to mess with some of the variables, you're now starting to wander away from what is a true copy of the Earth. So, right now, astronomers don't know of any Earth-sized worlds orbiting around a sun-like star within the habitable zone of that star, a place where liquid water could be present. Astronomers know of Earth-sized worlds orbiting around red dwarf stars within the habitable zone. They also know of Earth-sized worlds orbiting around sun-like stars, but not in the habitable zone. So they know of all of these combinations, but you don't get the 3 lining up perfectly. Sun-like star, Earth-sized world, habitable zone. We're still waiting for that, and that, we will shorthand call that Earth 2.0. But then there are other things. Like, if you get a Earth-sized world orbiting around a red dwarf star, it is, as you said in your question, almost certainly tidally locked, in the same way that the moon is tidally locked to the Earth. And the moon always shows the same side to the Earth, that Europa and like Europa, Io, Ganymede, they're all tidally locked to Jupiter. And you're going to get this situation across the entire universe. As long as your planets are close to the star, they're going to be tidally locked. But being tidally locked, like, the question is it another Earth? Well, no, it's a not a sun-like star, it is a red dwarf star. So now this is not Earth 2.0 because you've got this Earth-sized world in the habitable zone around a star that is nothing like the sun. And the implications of that is you're going to get this planet being tidally locked to its star. But, like the question I think you're asking is, does that disqualify it as a place to look for life? And not at all. I think for the longest time, astronomers thought, well, if you get this planet that's tidally locked to its star, then one face is going to be facing the star and it's going to be burning hot. And then the other side is going to be facing away from the star. It's going to be freezing cold. And the only place that you might be able to get some like reasonable conditions is going to be on the terminator around the planet. That sort of the in between the daytime and the nighttime, you're going to have like whatever, a few hundred kilometers where temperatures are reasonable, light is falling, it's not baking, but it's also not cold. And more recent exoplanet simulations show that in fact it's probably a lot more reasonable than that. That what we see are on tidally locked planets, you get these tremendous winds that are pulling hot atmosphere away from the side that's facing the star and driving it to the side that is facing away from the star. And that helps to regulate the temperature on this planet. And so instead of it being like it's just like a baking oven on the near side and then a freezing cold freezer on the far side, it actually would be more like a kind of steamy jungle. Like I guess what people thought Venus used to look like, I guess what people thought Venus was like before we realized that in fact it is hell. But so you could have, say, temperatures that are habitable. You have liquid water on the surface. You're going to have a lot of water vapor in the atmosphere. You could have a lot of plant life that is being supported in that, and animal life. And then you're going to have these winds that are going to be distributing that cool air around to the back of the planet. And then cool air is going to make its way back over through ocean currents and other sort of wind currents to help cool down parts of the planet. And so in the case of a planet that is tidally locked to its star, then you're probably going to get one hemisphere that is habitable. And then the part that's dark, it's probably, there's not a lot of sunlight that falls on the dark side. But you can also imagine situations where you have, say, a planet like a big gas giant like Jupiter that is orbiting around a red dwarf star or orbiting around some other kind of star. And the sort of the gas giant is tidally locked to the star, but maybe its moon is tidally locked to the planet, but is also orbiting around the star. Sorry. But it could have a moon, and the moon is tidally locked to the planet, but then the moon is also orbiting around this planet. And so from the perspective of being on the planet, you are seeing a whole day-night cycle as you go around your gas giant. So there's a lot of scenarios that people have thought through, and our ideas of what is habitable and what is not habitable has really widened. This whole idea of these Haitian worlds, where you've got this planet with a sort of thick layer of water and then a thick hydrogen atmosphere, that could actually extend way out from the traditional habitable zone, that this thick hydrogen could act like a blanket that keeps the water liquid well beyond, like maybe all the way out to, say, Jupiter. And so now your idea of like how big is the habitable zone really depends on the composition of the atmosphere. So I think, now that we've found a lot of exoplanets, now that we're really starting to make these kinds of observations, now that we're starting to realize these are the kinds of different variations that are out there in the universe, astronomers are starting to sort of be a lot more open-minded about the kinds of places that we should be looking for. And obviously, when you think about how we've got large amounts of liquid water underneath the ice here in the solar system at Europa and Enceladus, Pluto, Mimas, all these places, that also expands the places where we could potentially look for life in the universe. And so I think, are we going to find a carbon copy of Earth out there? Absolutely. It's just a matter of time before we find it. But is that the only place that we should be looking? Absolutely not. We should be looking at all the places. Rob Hawk, what happens with the Parker Solar Probe next? We'll cover Parker Solar Probe on Space Bites this week. So I haven't really brought myself up to speed on the flyby. They came within 7 million kilometers of the surface of the sun, which is like 4% the distance of the Earth to the sun. Got hit by a bunch of temperature, high temperature. It did its flyby on the 24th. And by the 26th, it had communicated with Earth and said everything was fine. So what happens next is more flybys. Christian Desailliers. Given the recent uptick in aerial phenomena reports of UAP UFO incidents, could any genuine extraterrestrial contact be effectively hidden from the professional astronomy community by governments? There is no way that you could hide the regular arrival of spacecraft from space and have it not be noticed by astronomers. And, I mentioned the incredible effort I mentioned early on about the impact that the Vera Rubin telescope is going to have on the astronomical community. It's going to be watching and scanning the entire night sky, looking for anything that's changing from night to night to night. And so, if a alien mothership wants to arrive in any direction that is seen by Vera Rubin, it's going to get picked up. And I think, like a lot of people think that the way astronomy works is somehow that there's a bunch of government astronomers and they are doing their work, and then they show their higher ups at the government, and the government approves whether or not they're allowed to go ahead with their research. But it doesn't work like that at all. Like, astronomy is a collection of professional and amateur astronomers. You've got small observatories, large observatories, space telescopes run by dozens of different countries in different locations around the world. There are tens of thousands of astronomers, and they work for universities, or they work for research institutes, or they work for government. The Vatican has an astronomer and their own observatory, and that they are constantly doing their work, constantly scanning the night sky. They are writing papers, and they're not going through any kind of gatekeeper. They're not going through some sort of censor process. They're just writing their paper. They're dropping it on the internet. There's things like the archive, where people will share the first draft of their science paper. There's the astronomer's telegram, where astronomers are just communicating in these, huge sort of Discord-like server where they're talking to each other. Anyone who wants can go in and listen and read. All the material on archive is free to read. You don't have to sign up for anything. You can just read all of the papers. And often the papers that you see reported on in journals, the first place you see them is on archive. Like, I'd say 80% of the papers that make it to journals were already published on archive. So the entire scientific process for astronomy, and really for most sciences, is incredibly open, just done at near real time, and nobody is watching, and nobody is like trying to stop anybody, and nobody's trying to oversee anything. And so, and the way these kinds, like, we think about Oumuamua, right? That when Oumuamua, the first interstellar object discovered here in the solar system, like, somebody reported spotting an asteroid that was moving on a trajectory that suggested that it might be moving on a hyperbolic trajectory, that it was going to probably leave the solar system. And then other astronomers turned their telescopes on the same object and evaluated it and confirmed the trajectory. And then people started to point larger telescopes at it. But the secret was out. Like, everyone was talking about it at that point. So I find this, I think people, before they have experienced what it's like to be part of the scientific community, and just how much of a cacophony of voices and programs and telescopes and places and NASA and space agencies and all this, before people experience that directly, they don't realize just how much of a kind of vibrant ecosystem it all is, and how impossible it would be to hide any information. And also, astronomers wouldn't shut up about it, right? That they love to explain and try to. And there's sort of a great saying. I forget how it works, but you don't have to worry about people stealing your ideas. If your ideas are any good, you're going to have to jam them down people's throats. That that the only way that people make progress in science really is by sharing the results, having debates and feedback with other scientists, and hammering away on problems until the truth finally reveals itself. And that just does not play well with secrecy. And so, anytime anyone suggests that there's some kind of, not even conspiracy, just like some kind of attempted cover up, some kind of way that various people in charge are hiding, like I immediately discount that idea because of just how open and vibrant scientific progress is. Astronomy 66. What about Viper? Any news will become of it? Cancelled. Mercury and Venus are not tidally locked to the sun. Dean Hupp. Do you think that string theory is on the right track? It feels like a wrong turn to me. All right, so I'm going to... well, anyway, that falls under the... I don't know if you missed my rant at the beginning. Did I do this too recently? I think I did. Yeah, okay. So sort of similar to what I mentioned earlier, like I'm a journalist, not a scientist. And so the only people who I think are kind of qualified to know whether or not string theory is a good theory or not are the people who have done enough of the math and done enough of the research to be able to get to the point where they can evaluate it on some kind of objective criteria. And I'm not capable of doing that. And I think there are a lot of charismatic people, some here on the platform, who will say things about string theory, and they are lone voices. Now, they may speak for a certain subset of researchers who believe a certain thing about a certain kind of research direction, but then there's another group of people who feel a different way about that research direction, and that there is a scientific consensus. You can go and poll most physicists about what is the state and the nature of string theory and how does it play into research, and you'll get this nuanced understanding of where it stands. But there's no scientific consensus of it. And so for those of us who are like not scientists, I don't think it's right to have a position at all. Like, we're going to let the scientists hash it out until they come to a scientific consensus. And when they do, I will adopt it, because I am ill-equipped to know better. So mouse destruction, do you think it's increasingly likely that aliens don't exist? So, this is the thing where I do hold an opinion, which is that I think we're alone in the universe, but I have no scientific basis for that. But I wonder, is that position spreading? Have I messed this up? I wonder if I'm being bad. QFT is not too hard for you. Yeah, yeah, it is too hard. Well, like, I think that anybody can become sufficiently knowledgeable about any scientific pursuit that they want to. It just requires a ton of work, right? When you think about the books that you have to have read, the math that you need to be capable of doing, the technical papers that you need to have understood, that you need to be able to contribute original research to the field to get to the place where you can make a meaningful contribution to the field so that you can then judge its viability as a scientific theory is a tremendous amount of work, and we have a limited lifespan, we have a limited amount of time. The thing that I try to get better at is being a science communicator, but the thing that I have to then sacrifice, I've had to sacrifice my ability to be a computer scientist because I haven't done that for a long time. I stay abreast of the work, but I don't really hold opinions about various stuff. So I think it's I just think, you're saying QFT is easy. I don't think so. Um, Dougal, do you think elements on the island of stability exist somewhere out there? People always ask this question that, you know, is it possible that there are elements with many more protons than the ones that we find here on Earth, or even the ones that we've been able to create in the lab? And I don't know what the highest number in the periodic table of elements is, but that's something that can only exist for a few attoseconds before it decays. It requires enormous atom smashers to be able to, create these larger and larger atoms. And so, the amount of energy that humanity is able to bring to bear in a small space with something like the Large Hadron Collider is still orders of magnitude, I think like 6, 7 orders of magnitude less than what the universe is capable of doing with supernovae and things like that. And so we're still a long, long way from being able to create anything that holds a candle to what supernova and neutron stars, colliding neutron stars, can do. And yet we here on Earth, we're left with a certain number of elements. We're left with iron and gold and carbon and all of these different elements leading up to a certain point. And then beyond a certain point, we don't see any of those heavier elements. They've all decayed, radioactive decay. And so the most powerful atom smashers in the universe have not created anything that is beyond what we find here on planet Earth that we can tell. And so you can sort of safely assume that there are no more stable atoms further up the periodic table beyond what we've already discovered. Now, in the zillionths, which I believe is a technical number, of a second after these, giant neutron stars have collided with each other, you're going to have unimaginable forces where you are just a fraction away from the amount of force required to turn matter into a black hole. You can imagine there are some monster atoms being formed, but they are decaying almost instantly into other things. And in many cases, it's that decay of elements that is actually driving a lot of the energy coming out from these collisions. So, the universe is capable of creating elements wildly beyond anything we can do here on Earth, and yet we know that they must decay almost immediately. Hmm. Simon Simon Farmer. Fraser, I'd like some more clarification. A few months ago, when you said there were multiple kilonova events detected, but from my research, it's more that others were inferred. I think there's 3 kilonova events. I can look it up. Not detected in gravitational waves. Let me see. I think there's 3. But I'll get the... So in 2017 was the big one. And then in 2018, there was GRB 150500101b, which was analogous to it. Had the same kinds of gamma ray optical and X-ray, but it didn't have the gravitational waves. And then in 2021, there was another one. And then it looks like there was another one in 2023. So it's about 4, I think, at this point. And then absolutely, there were, there's indirect evidence that there was a kilonova that happened before the solar system, like 100 million years before the solar system formed. That's cool. Church discography. We recently learned that Dr. Vera Rubin will appear on a U.S. quarter in 2025. Are there any scientists you want to see honored on a coin? That's a tough question. I wouldn't want to have to make that choice. Tim Gordon, what's happening with the LHC? Nothing. I think they're in maintenance mode right now. No, they were opened in 2022. Okay. Let's see. So they had a winter maintenance. That was 2022. So the 2024 run ended on October the 28th. So they're on another break. What? I watched the video. I watched you for 20 years and you inspired me to become a space journalist. I was that for 18 years and you and Pamela are directly responsible. I'm trying to figure out the math here. So you watched me for 20 years and then you were a space journalist for 18 years. So that's like 38 years. I definitely haven't been doing this job for 38 years, but that's amazing that we inspired you to become a space journalist. Simon Farmer, what's the impact of not having detected the gravitational waves with LIGO just not turned on? I mean, the impact is you just don't get that really solid gold star confirmation that what you're seeing was a kilonova. So you're seeing the optical afterglow of the kilonova. You're seeing the kinds of manufacture of elements in the explosion. And, there have been these kinds of short period gamma ray bursts for a long time. But nobody knew sort of what was causing them. There was a lot of theories, but LIGO, by detecting the gravitational wave signatures, was able to see hear the neutron stars spiraling around each other and colliding. And that gave this connection that you saw the visual version of the kilonova or the short period gamma ray burst. And you could tie that to this collision between neutron stars seen by LIGO. And so you had finally this conclusive answer to what was causing these short period gamma ray bursts. But short period gamma ray bursts have been seen for a long time. And we know about the long gamma ray bursts, the ones that are caused by collapsing stars, but it's the short gamma ray bursts that are the ones that were that were a mystery. And there's a bunch of ideas, and even still, kilonova only explains some of the short period gamma ray bursts. So that was the missing link. The LIGO was the Rosetta Stone that told us what it was that we were looking at. El Cosmodos Drago. What's your view on the whole NASA is avoiding looking for life conspiracy between delays to MSR, Dragonfly not going to lakes, and placing the Uranus orbiter ahead of the Enceladus orbiter lander? Well, I think that's ridiculous. Obviously, that that there's any kind of vast conspiracy that says that NASA or any space agency is looking to delay. I mean, you may have the Mars sample return mission sort of falling apart because the budget was starting to expand outside of what anyone was willing to pay, but the Chinese are still planning to do their sample return mission. I think the whole search for life took a serious blow back in the 1970s with the Viking experiment, right? So, when the Viking landers went to Mars, they had these really cool experiments on board where they would pick up some Martian regolith, they would feed it some nutrients, they would increase the temperature, give it some water, and would then measure the outgassing that happened in the experiment, and that would tell you whether or not there was just microbes living in the regolith. And the problem was that the outcome was inconclusive. Now, some people are absolutely certain that life was found on Mars, and other people are not sure that life was actually found on Mars, and they think that in fact these are just natural outgassing from the kinds of chemicals that were in the regolith, and no one can really double check. You could send another mission, but you might just get another inconclusive result. And then you had the Allen Hills meteorite, where if you remember President Clinton announcing that life had been found on Mars, and here we are 20 years after that, and nobody thinks that meteorite was evidence of life on Mars. It was interesting, but definitely not conclusive. And so this sort of running forward to try to prove that there's life on Mars or on any other place in the solar system had to slow down. And that they wanted to build this overwhelming, conclusive case that there actually is life on another planet, or if there isn't. And so that's how you saw Spirit and Opportunity, which were just looking for any possible evidence that there was ever water on Mars, and they did. And then you got Curiosity, which was trying to find out whether or not there had been water on Mars for long periods of time in the ancient past, and it did. And now you got Perseverance, which is saying, were there conditions for life? Were there the kinds of organic chemicals? Were there the kinds of raw materials available to be present for life? And in that, the jury is still out. This found a lot of really interesting things, but the work is still ongoing as Perseverance still searches around. And so, all of those things that you mentioned, Dragonfly is not going to the lakes, there's lots of good technical reasons why you wouldn't send a helicopter to the sort of extreme poles of Titan. Having a Uranus orbiter ahead of an Enceladus orbiter lander, I mean, landing near the tiger stripes on the south pole of Enceladus is really complicated. And a lot of this stuff is all still up in the air. I mean, no firm schedule has been set for when these various missions are going to go. But, finding evidence of life in the universe, finding evidence of life in the solar system is one of the most important discoveries that humanity can possibly make. It tells us that life has, maybe formed independently on other places here in the solar system or out there in the universe, or maybe we're related to life here in the solar system through panspermia. But either way, you get one of the most impactful sort of pieces of scientific knowledge that has ever fallen into the hands of humanity. And so you want to be sure. You don't want to go through times where people are inconclusive. Nobody argues that water was once present on the surface of Mars. The evidence is overwhelming. And that's what you want to get to with life. You want to go have the evidence be overwhelming. Nobody questions it. But that requires being very, very careful, doing a really good job, sending the right equipment, with the right resolution, the right experiments, to be able to get you a conclusive result. And when you consider how far away it is and how difficult it is to get to Mars or Enceladus or Uranus, that sending sufficient equipment to give you a conclusive result is an expensive process. And yet there's, we've seen what happens if you take it, if you don't get the conclusive result, then people just argue, and I think it makes the search for life just in general look less legitimate. So I think that's all that's going on. What's up with Planet 9? Any new developments? Nope, but wait for Vera Rubin. Lonnie Vanader, how close can we get to the speed of light right now? Depends on what you're talking about. We can get particles in the Large Hadron Collider to 99 point, a whole bunch of nines % the speed of light. But they're just, individual particles, electrons, protons, things like that. Let's see. All right, we'll do one more and then go to overtime. Squeal, what do you think about the idea of SpaceX sending starships full of Tesla bots to Mars to prepare for human arrival? Are those bots even able to survive on Mars? That's really interesting. So, would that work? Sure. We've sent robots to Mars, and so if you sent a whole bunch of Tesla bots to Mars, could they survive? They probably could survive, although they're not built for the kind of environment that Mars can throw at them. When you think about a rover like Curiosity or Perseverance, it's custom built to be able to handle, both its shape, it's squat, it has 6 wheels, rolls around, as well as all of the internal workings of this rover were designed to be hardened to be out there exposed on the surface of Mars for long periods of time. It's made of metal. All of the computers on board are hardened, radiation hardened for space, are made out of relatively simple computer components that we know work for long periods of time in the rigors of space. And so think about a Tesla robot. I mean, is it made of plastic? How well will plastic work out there on the surface of Mars for long periods of time under the intense radiation from the sun. It'll crack. You'll probably need to change what these things are made out of. Think about the computers that are running on them. I mean, they're running on incredibly advanced, very, small nanometer chipsets, because they require a ton of processing. While a Tesla bot, it probably has, many orders of magnitude more computing power than Perseverance or Curiosity. And so they would be very fragile, and the odd cosmic ray would cause all kinds of problems to their functioning. And then they require a certain amount of infrastructure that these robots are going to need a place to charge themselves. Okay, well, you're going to have to bring the charging situation. Well, the charger is going to require solar panels or a nuclear reactor. Okay, you're going to need to send the nuclear reactor and the solar panel array that's going to be able to keep all of these bots going. And then what are they going to be doing? I mean, are they going to be digging regolith with their hands? No, you probably want an excavator. Okay, you're going to be sending a giant robotic excavator that's going to go to Mars. It's going to be digging. Are they going to be driving the excavator? So, I think that we're at this point where like a humanoid robot will be really useful here in our house, doing my dishes, unloading my dishwasher, doing my laundry, working in construction sites, in places that were built for human beings, that you need to be able to have a robot shape that can navigate around a human infrastructure. But once you're out on the wild openness of Mars, then the body plan of the Tesla bot just doesn't make as much sense. That you're going to want something that is just only a bulldozer. It's a Mars bulldozer, and its job is to push around regolith. Another robot is a rock grinder that's only job is to take chunks of regolith and turn it into a fine powder. And, it doesn't look like a humanoid robot at all. So I think the humanoid type robots will only show up on Mars after we have the environments that human beings are already going to be living in, and you need robots that can work within those environments. Questions do we have? All right, let's do more. Astronomy 66. I don't understand the Hubble tension. How will resolving the differences in the expansion rate calculations advance science? What will scientists be able to do with this information? So the Hubble tension, this is a measurement of the expansion rate of the universe that doesn't agree with two different measurements. So there are many ways to measure the expansion rate of the universe. I mean, we know that galaxies are moving away from us in all directions. And when you measure that expansion rate of the universe, you get one number. And that also you can measure the expansion rate of the universe in the cosmic microwave background radiation. And when you compare the measurement in the CMB versus the speed of galaxies moving away from us, you get a different number. And the number is close, but the number is not the same. And for the longest time, the error bars of the two numbers overlapped. And so people just assumed that the error bars were going to go away, that the two measurements would finally settle in on what is the right number for the expansion rate of the universe. And what they found was as they got better and better at measuring the expansion rate, the two error bars narrowed down, but they didn't overlap. And so you got these two numbers. And now the people who are measuring the expansion rate of the universe based on the galaxies are really certain. And they've double-checked their numbers. And they've double-checked their numbers and triple-checked them. And then the people who've measured it from the cosmic microwave background have done the same. And they are absolutely sure that they have measured the expansion rate of the universe properly. And those numbers disagree, and that is the Hubble tension. So why is that important? Well, where it's important is that you have to explain it, right? Why? How could if the expansion rate of the universe is really well understood and can be tracked over vast periods of time, how is it that you get these different numbers? So the one possibility is that it's a measurement error, that someone has made a mistake somewhere with either the measurement relatively nearby or the measurement that is made in the cosmic microwave background. That's almost always the answer, is that somebody's made a measurement mistake. And yet the people who have made these measurements are the best in the business and have done really good work. People have double checked their work. People have double checked the double checking of the work, and these numbers hold. So the more interesting thing is that the theories themselves about the universe are wrong. And so when you think about the expansion rate, you have to take in these underlying assumptions about the way the universe works. What is the amount? What? Hold on, my card ran out of memory. That's unfortunate. Hopefully that one has room. Okay. So when you think about the measurements that have been done and you've ruled out the measurement error, then what you're left with is that your underlying assumptions, your theories about the universe itself, the way the universe has evolved over time, are missing something, that there is new physics, that maybe at some point, at some weird middle time over the expansion of the universe, things sped up and then slowed down again, or maybe have continued to speed up and then only recently slowed down, or maybe it sped up at a time before that first measurement was done. And each one of those then has to be explained. Like, what could cause the universe to change the rate of its expansion beyond the factors that have already been accounted for? And that's what makes this really exciting. People call the Hubble tension. It's like or they call it the crisis in cosmology. And a crisis makes you think there's something bad happening. But this is an opportunity, because the theories about the nature of the universe haven't provided a lot of places to look for things that don't fit. It's when you look for the things that don't fit that you can start to expand the theories and start to understand things at a more deep level. It's the weird stuff, the anomalies. Those are your guide to deeper theories about the nature of reality. And cosmologists are fortunate enough to be getting these cracks, these weird anomalies, and they're then having to try to chase them down and figure out the source of them. So I think, the Hubble tension is this sort of revolution in our understanding of the universe, an opportunity to go back and figure out some of these deeply held understandings that so far have beautifully explained the evolution of the universe over time. And now you can see that there is deeper theory. And we know there must be deeper theories. When you think about the fact that quantum mechanics and gravity can't be sort of connected in any meaningful way, it tells you that there's more to this universe that we understand. Why was there more matter than antimatter in the early universe? Why do we see these large-scale structures of the universe that shouldn't be possible? And it's only in starting to find these interesting anomalies that you can start to more deeply understand the laws of physics in the universe that we find ourselves. So it's a really exciting time in cosmology, and we're going to see a lot of really interesting work get done. And good news is that, like, a lot of really great tools have come online in the last couple of years. We see the Euclid mission, there's the upcoming Nancy Grace Roman, there's the Vera Rubin Observatory, there's the DESI, the Dark Energy Survey Instrument. So there's a lot of really great tools that have just come online to try and help answer this problem at a time when we need the tools. So it's really good timing. I hope that helped. Rev MSJ. What happens when we reach the great attack? Rev MSJ. What happens when we reach the great attractor? Something or nothing? So from what we can tell, the great attractor is a concentration of galaxies on the far side of the Milky Way. It just happens to be that the core of the Milky Way obscures our view from the far side of it. But thanks to infrared telescopes, thanks to radio telescopes, we're mostly able to see through the dust and gas of the plane of the Milky Way and see what's going on the far side, to see all of these galaxies that are sort of gravitationally connected, bound as part of the great attractor. And like, what is a great attractor? It's a galaxy cluster that we are a part of, a larger sort of concentration of galaxies in the universe. And so, you know, what happens when we reach it? Well, we're kind of already in it, and we will never reach it. So, you know, the Milky Way is bound to Andromeda and M33 galaxy. Sort of those are the three big spiral galaxies, and then a cluster of dwarf galaxies. And those are the ones that will eventually merge into some larger elliptical galaxy billions of years down the road. But all the other galaxies that we can see in the universe are moving away from us, and in fact seem to be accelerating away from us thanks to dark energy. And so we will always be moving away from the great attractor. Now, we are still gravitationally influenced by the galaxies in the great attractor. It's changing the direction that the Milky Way is moving away from the great attractor and other galaxies in general. But we will not end up inside the great attractor. We will only end up bound up and form a large, we'll only merge with Andromeda, the Triangulum galaxies, and all those dwarf galaxies around us. Everything else will just move away faster and faster and eventually fall over the cosmic horizon, including the entire great attractor. Okay. All right, so I'm going to stop that. And then I'm going to stop this. And then we'll go into overtime. QA is this. 284. Hello, patrons. It's time for the overtime audio for QA 284, 285, which was recorded on Monday, December 30th. That changed. Okay. All right, let's get into the overtime questions. Unknown caller, what do you think of timescapes? So this timescapes is this new theory that's sort of coming from the dark energy survey that is telling us about the potential for, a possible explanation for dark energy, that it doesn't exist, that when you account for the, when you count for like the time dilation for these sort of concentrations of matter versus the super voids, then that accounts for the weird changes in velocity that we see for these galaxies that are moving far away from us. And I don't have an opinion. I am a science journalist, and so it's a fairly new theory that a lot of people are quite excited about, and there's a really interesting correlation between this and it's been considered an alternative explanation, and it's nice because it makes it disappear, right? It makes you don't need to have dark energy if there never is any dark energy. That makes no wonder you can't find it because it doesn't exist. That's very satisfying. But you have to, this theory has to explain all of the observations that have been made of dark energy so far at all the different time scales. And it's just going to be a matter of time before, we know for sure that that is the theory that's going to sort of be the one that's accepted. But I will definitely do an interview with somebody on the channel who understands this very deeply and can sort of talk through all of the ramifications of it. So we will, so stay tuned for that. But it's, it's very new. And I think a lot of people find it very emotionally satisfying, which is what's making it gain traction. But I'm more interested in the scientific consensus on what the people who understand the work deeply, what are the mistakes that I am ill-equipped to answer. I think a lot of people just, they don't like the idea of dark matter. They don't like the idea of dark energy. And like they have an emotional response to it. They're like, I don't like it. Okay, you don't like it. But that shouldn't be a reason why, there isn't scientific consensus about this theory. So, we will find out. Jacob Soley, should Mercury be demoted to dwarf planet? No. I mean, like, I don't like this definition of dwarf planet versus any at all, because speaking of things that people have an emotional response to, I think people are, the fact that Pluto was demoted from planethood and made into a dwarf planet has made them very angry. And so now they're looking to kind of rules lawyer all the different possible variations of planets. And I don't have an opinion. Like I literally couldn't care less about that. Because like Pluto is amazing and it's out there and it exists. And it's just a member of and like any definition of planets is going to be arbitrary, and you just have to decide, right? Like, is a icy, can any object like the size of Pluto or larger be a planet? Well, then Eris is a planet. Then Ceres is a planet. Then you probably can make the case that there are about 12 planets or more in the solar system. If it is, hydrostatic equilibrium, then you could make the case that there are dozens of these objects in the solar system. What is the difference between a moon and a planet? If it has hydrostatic equilibrium, well, you can make the case that maybe there's about 120 planets in the solar system. So I don't really care. I have no emotional investment either way. And so should Mercury be demoted to a dwarf planet? I mean, it's pretty big. It is, it's not as big as Ganymede. Why does Ganymede get to be a planet? Because it's all arbitrary. Tommy C., how many Starship launches will there be in 2025? And what will be the most advanced flight profile? I have no idea. Let's find out. Like, I know, I must be enraging. I don't know. How can we know? We saw 5 launches of Starship in 2024. Elon Musk and SpaceX say they're planning launches within a couple of weeks, and they have very important goals to be able to accomplish to fulfill their contract to NASA. They have to demonstrate that they can launch, that they can do orbital cryogenic propellant transfer. They have to demonstrate that they can fly to the moon, land on the moon. Like, it's a lot of things that need to happen between now and when Artemis 3 launches to the moon. So at the same time, there's a new administration coming into NASA that's going to mix things up. Could very well be that certain aerospace manufacturers are going to receive additional contracts. It's possible that other aerospace manufacturers are going to lose contracts. It's possible that missions are going to be canceled entirely. Does SpaceX need to provide the human landing system if the Space Launch System is canceled and the Orion capsule is canceled and Artemis 3 is canceled? So all we can do is wait, watch, and report as they happen. Rev MSJ, I wonder if gravitational waves get redshifted like light waves. Yes, gravitational waves redshift in the same way that light redshifts. So if the universe, as the universe expands, gravitational waves will also have their wavelengths expanded, stretched out. Big fish out of water. Maybe the other side of the universe is mostly antimatter. If something was completely over the cosmological horizon, then, and if it was antimatter or whatever, we would never be able to know. So who knows? But, we can see pretty far away out into the universe, including seeing galaxies that are billions and billions of light years away from us. And if those galaxies were made of antimatter, or if there was like a region of the universe that was dominated by antimatter, then there would be this boundary between the parts that are dominated by antimatter and the parts that are dominated by matter. And you would expect to see gamma radiation where the antimatter and matter are annihilating with each other and producing enormous amounts of gamma radiation. We would see walls like fireworks, right? Where the antimatter space is meeting matter space, and we don't see that. Like, it just appears to be matter all the way out. Shard, is there no hope for SLS? We don't know. Like we just don't know what's going to happen. I mean, we are now a week away from the new administration taking over. I'm not sure when it happens. Anyway, a couple of weeks away from the new U.S. administration taking over. And they've said in advance that they plan to streamline and cut programs. And that people have their eye on SLS, which is already, people are having a hard time justifying spending $4 billion per launch of that enormous rocket. It's a lot of money that could be spent in other ways on other things. And is it the most efficient use of U.S. taxpayer money to even accomplish these goals of having humans land on the moon? There's a lot of people that are like, nope, cancel SLS immediately, day one. At the same time, right, we know that the Chinese are planning to send humans to the moon by 2030. The U.S. is running out of ways to be able to stay apace of what the Chinese are going to be doing if they want to be able to land humans on the moon again for the second time before the Chinese do. Well, they're going to need to work within an existing set of hardware that's already been developed. The Space Launch System is capable of throwing the Orion capsule at the moon. That rocket already exists. It would be sort of crazy to just throw that thing away. But at the same time, if you want to have a long-term established presence at the moon, you're back to having to spend $4 billion per launch. That gets really expensive. And so it's a very complicated situation. You could say, well, let's give all the contracts to SpaceX. They're building Starship. Well, Starship hasn't proven that it can fulfill all of the tasks of carrying human astronauts to the surface of the moon and back safely to Earth. Well, what if you use some kind of combination where you use Starship to be able to launch the heavy material, you launch an Orion capsule on a Falcon Heavy, it docks with Starship, Starship takes it to the moon, then the astronauts get onto the, like, now you're coming up with a totally new configuration for the way you're going to run the Artemis program that still requires more than a dozen refueling flights to be able to fill up the human landing system. The like we just don't know what's going to happen right now. There's no way to know until things start to happen. And so like I know we want some kind of certainty before these things happen, but we can't. There's too many moving parts, too many variables, too many political interests, too many people involved. The combinations are beyond comprehension. I'm sure there's a metacalculus vote somewhere that's people have already sort of calculated. Someone should check what is the what is the over under on SLS getting canceled. Dougal, do you have any 3D printers? I don't. I bought a 3D printer for my wife a couple of years ago, but it was a mono price one of the sort of the small mono price 3D printers, and it was really finicky. And so we made a couple of googags and said, "Oh, this isn't very fun." And so I sold the printer again on Facebook. But I've been watching videos about the resin-based 3D printers, and especially how people can 3D print figures for their role-playing games. And I'm starting to run a role-playing game, Dungeons and Dragons, for my kids, my adult kids and their adult friends, and thinking, oh, okay, it'd be cool to get some figures and set up some maps, and we could do some actual more tactical combat. So I'm kind of tempted to get a 3D printer, but I feel like, is it just another place to hang my laundry off of after a while? So talk me into getting a 3D printer, a resin-based 3D printer. So, I mean, for those of you who are fairly new to the channel, I'm going to blow your minds. I used to work for Games Workshop. So I used to paint figures as my job, teach people how to paint figures. So it's like a weird old skill in my history. And so I would love, and I gave away all of my figures. Like, we got a ton of really cool figures from corporate head office, and I had all these really cool limited edition figures. I had a whole set of Harlequins for Warhammer 40,000 that I had painted very carefully and deployed in our games of Warhammer 40K. And I got rid of them all when I became an adult. So, yeah. There you go. All right. Starshine says, get a resin 3D based printer. Revis chases all the cool nerds have resin 3D printers. So yeah. All right. So your expectations of minifig quality is higher than most. Yeah. Dougal, do you have an asteroid named after you? I do. Let's find the asteroid. So it's asteroid 158092 Fraser Cain. Let's see. There you go. There's my asteroid. It was discovered in 2000 by a guy named Jeff Medcalf, and he was the blue collar scientist, and he was a science communicator and blogger and podcaster and an asteroid hunter, and he found a few dozen asteroids and then named them after various people in the science community at the time. And then he died of cancer at like 40 years old, 42. So yeah, Jeff Medcalf, and it's heartbreaking. So I'm so grateful that he, for this brief moment, I was a member of a community where he was handing out asteroids to the various people that he liked, and yet I'm just heartbroken that he passed away at such a young age. So, yeah, it's cool though. You can look up. And I've lost this. Scott Manley has an asteroid named after him as well, and he found this website where you can find every observation that's ever been made of any asteroid, and so he was able to find all the observations of his asteroid, and I did the same thing. I was able to find all of the pictures that were taken of my asteroid, but it's so I don't keep track of it. I should at some point. I'll point the telescope at it and see if I can, when it hits opposition, I'll try pointing the telescope and see if I can actually detect my asteroid. It's in the main belt. Petrie, why does it matter so much who goes to the moon first? It really doesn't. I think that back in the 1960s and 1970s, where nobody had landed on the moon, then I think it really does matter, right? It's a national pride. I mean, it's like, why compete in the World Cup? Like, you want to demonstrate a certain capability, and being the first nation to set a human on, have a human set foot on the moon is an amazing accomplishment. And the Americans did it. They pulled it off. And the Soviets congratulated them based on, tracking the movements of the spacecraft. And even now, because it's such an incredible feat, you have these conspiracy theories about it. But it's been done. And so now anyone who sets foot on the moon after this is going to be the second nation to set foot on the moon. So there is no rush to get back to the moon. But I think that there is this competitive nature from countries like the US who feel like the way that you demonstrate that you are the most technologically advanced, or one of the most technologically advanced countries in the world, is that you demonstrate this ability to send humans to the moon on, when you want to, on your whim, right? And this is the thing that China's doing. Like, the way China is going to demonstrate that they are a modern technological nation capable of doing anything any other nation can do is they will have humans set foot on the moon. It's driving a lot of their space exploration efforts. It's a point of pride. It's a way to encourage people to go into high technology fields, to go into science, engineering, math, things like that. And that is the culmination. It's like a binary event. It required 30 years of investment in technology and education and, leading to this moment where a person sets foot on the moon, and it's a way to demonstrate. And so I think, it doesn't matter, and yet it matters. Boy, it would be awesome if Canada was the second country to have a human, set foot on the moon. I would be very proud if we did that. So we won't. It won't be us. But I think, in my perfect world, any exploration of the moon would be done as an international collaboration, in the way that the International Space Station is an international collaboration, except for the Chinese, right? So it would be great if we had a moon base that was built and populated by people from around the world working in collaboration, that shows that despite our issues that we have down here on planet Earth, we can get along well enough to build a community on the moon and have people go there. That would be incredible. And that would be my preference. And so if, I don't know, 20 people could set foot on the moon simultaneously, erasing this idea, from 20 different nations erasing this whole need to have a new moon race. That would be my perfect scenario. But since that's not going to happen, I just want anybody to set foot on the moon next. Vaughn's a fan. So do you think Canada should become the 51st state? Then we can claim that we got to the moon first too. Or the United States becomes the 11th province, and by landing Canadians on the moon, that's the more legitimate way to do it, right? Because if Canada becomes a state of the US, well, then the Americans did it, even though it would be a Canadian setting foot on the moon. But if the US is willing to become our 11th province, then no matter which person from either nation sets foot on the moon, it was a Canadian. So think about that. And unlimited maple syrup from the Strategic Maple Syrup Reserve. Nathaniel Stapp. Fraser, what could be done to lock carbon from the Venusian atmosphere? Would that drop the pressure enough to make it habitable? So this question of how do you terraform Venus? It comes up all the time. I'm going to drink some water before I answer this question. Okay. Right. So how do we terraform Venus? How do we make it livable and not a terrible, torturous hellscape? And so there's sort of two parts to this. One is you have to lower the temperature, that you have to block the light from the sun from reaching Venus. And there's been a lot of ways proposed to do that, but probably the most straightforward way is to position some kind of sun shield at the Sun, Venus, L1 Lagrange point. Why? A Lagrange point question. And so you cast a shadow from this sun shield over Venus. No sunlight is falling on Venus. And then Venus will start to cool down. And it will get colder and colder and colder. And eventually Venus will get so cold that the carbon dioxide in the atmosphere will just start to snow. It'll snow and turn into dry ice on the surface of Venus. So now you've got, I don't know how many, thousands of meters thick of dry ice, of frozen carbon dioxide on the surface of Venus, but you have to get rid of it. You have to lock it away. And so there are very specific chemicals that you can use to mix with carbon dioxide. And we get that here on Earth. We have limestone. I think it's a calcium carbonate. So if you could drop enormous amounts of calcium, it would bind with the carbon and lock it away. I think magnesium is another possibility. And there's probably enough calcium and magnesium and other elements that would be able to form these kinds of compounds across the solar system. So you need to find an asteroid, grind it up, extract the magnesium, sprinkle the magnesium down onto Venus, lock away the carbon dioxide until you get down to the level of atmospheric density that, when you're left with enough stuff that when it sublimates, again, when you turn the sun back on, then it won't be this overpowering atmosphere. But it's pretty tricky. A long time ago, I think it was like Carl Sagan had proposed this, that they thought that maybe there was a way to do this biologically, that you could somehow release like some extremophile into the Venusian atmosphere, and then it would slowly bind up the carbon dioxide into, and then they would die and they had a layer, and then more would happen. Eventually, it would start to lock away and sequester more and more carbon. But the problem is that the heat is so high that when the thing dies, it just turns back into carbon dioxide again. So there's no way to sequester the carbon dioxide without some additional chemical that you'd have to deliver to Venus to be able to make that happen. Tommy C, do you think you can get an interview with Jared Isaacman after he's confirmed? Maybe. I don't know. I have never interviewed a NASA administrator before. I've interviewed second in command, but I've never interviewed an actual administrator. But yeah, if they're trying to get, I tried to do an interview with Jared Isaacman before he became a potential NASA administrator, just to talk about the Polaris program and how they could try to rescue Hubble. And they ignored my requests. So I don't know why I would, I don't know why that would happen. Mouse destruction. Is there any proof that antimatter annihilates? I notice we have never tried it. We have tons of proof. A PET scanner in a hospital is a positron emission tomography, and positrons are antimatter. So hospitals can generate antimatter, and then the antimatter, and I forget exactly how it works, but you eat particles that then create antimatter reactions in your body. I forget how it works. I forget how a PET scanner works. But hospitals are generating antimatter. And so yeah, antimatter annihilation is well understood. Fractal Builder, what would we do if we got our hands on exotic matter? What kind of exotic matter? You need to be more specific about the possible kinds of exotic matter that we could get our hands on. So, I mean, are you talking about strange matter, quark matter? A neutron star is an exotic degenerate object, white dwarf, black hole. So what would we do if we got our hands on it? We would study it, is what we would do. David Dull, should the name of planet Uranus be changed? Absolutely not. It is hilarious. Sean E., when can we send a probe to Uranus? There have been plans to send missions to Uranus and to Neptune for, like a decade now. And it sucks because we've got lots of information about Jupiter. There was an orbiter that was sent to Saturn. But the only close-up images that we ever have of Uranus and Neptune came from the Voyager spacecraft doing this single flyby back in 1986 for Uranus, 1989 for Neptune. And that's it. That's all we've ever seen. We've got, the Hubble Space Telescope, James Webb, are able to take images of Uranus and Neptune when they reach opposition every year. But that's really far away. And so we haven't had any close-up images since then. So but the problem is that they're really far away, that you need to send a spacecraft for like a decade, especially if it's going to be in orbit. It's going to go into orbit around Uranus and be able to try and look at it, look at the moons. You're looking at a very long time frame. And so there's only so many flagship missions that NASA has in the pipeline at any one time. And so, we report on really interesting potential orbiters, landers to the Uranus system. I mean, Neptune's maybe a little even more interesting because Neptune has Triton, which is one of the most fascinating moons in the solar system. Like, it's probably a captured Kuiper Belt object. It orbits in the opposite direction from all the other moons, really large moons in the solar system. It has geysers coming off of its surface in the same way that Enceladus does, but they're dark. It's like, what's going on? And so if you send a mission to Neptune, you could also study Triton and get a lot of information. Please don't ask the same question multiple times. Like, we've got it. Nathan Strapp, is there any word about the Viper lunar rover being rescued? No, not that I'm aware of. Mustafa Al-Masawi, if you suddenly had access to another 50 billion, what large-scale unfunded projects would you like to see happen? Yeah, I think, you know, in addition to the existing $50 billion that I'm already using, yeah, it's like $50 billion is a lot of money. So you could do a lot of really interesting things. I think the most impactful mission that we could probably do is to send a spacecraft out to the solar gravitational lens, right? This is the place 500 plus astronomical units away from the sun where the sun acts like a natural lens. And it would be so powerful that if you had like a 1 meter telescope, it would be capable of resolving an exoplanet on the other side of the lens at a megapixel resolution. And so we would see mountains and forests and oceans, city lights on another planet, and that there's nothing that we could build for, you know, that could match the capability of going out to the solar gravitational lens. But it's really far away, that it is much farther away than the Voyager spacecraft have gone so far in 50 years of flight. And you'd want to do it within a single human lifetime. So I think going out to the solar gravitational lens is the culmination of all of our technology, right? That, as with like landing humans on the moon, that step that Neil Armstrong took to get off the LEM and land and set foot on the surface of the moon, that was the culmination of all of that work that had come before. And so for us to be able to actually get out to the solar gravitational lens and to be able to observe an exoplanet, we need to find exoplanets. We need to find the possible targets to be able to point the solar gravitational lens at. We need to revolutionize the propulsion systems that we can use to get us out there in some reasonable amount of time. So there's a lot of underlying technology. So I think, you know, if I had $50 billion to spend, I would be building up the tech tree to get us to looking at another Earth from the solar gravitational lens. My YouTube channel. If we found life on Europa, like 1 inch small creature, do you think that would change the way we think about everything? It would be really exciting if we found like a 1 inch creature, you know, something this big. That would be amazing. I mean, right now, if we found a single cell of bacteria or archaea or some really simple organism that did not evolve on Earth, that does not share a common ancestor with us here on planet Earth, it would be mind-blowing. It would be the most important, one of the most important scientific discoveries in the history of humanity. Seeing a tiny little European whale would just take that to the next level. So any life at all, viruses, anything would be just an incredible discovery. Aaron Calhoun, do you think we'll ever find the stars that were born in the same cluster as the sun? Actually, astronomers think they've already found at least one of the stars that was born out of our solar nebula. And so the way they do this is sort of 2 ways. They used Gaia to measure stars that were moving on roughly the same velocity around the center of the Milky Way. So, you know, that they started at a common location and have drifted a bit, but are still sort of moving in a similar orbit around the Milky Way. And then they also used a different catalog to look for stars that have a similar chemical composition to the sun. And they found at least one star that is moving in a similar orbit and has a very similar chemical composition to the sun. Now, obviously, we can never really know if we are, if that was one of our stellar siblings, but it does appear that stars that are born in the same stellar nebula share a very similar chemical fingerprint. And so if we find other stars in the Milky Way that have the same chemical fingerprint as the sun, and they get that other piece of evidence, they're moving in roughly the same orbit as we are, that tells you that, yeah, this probably is a star that formed in the same nebula as us. And they've already found one, and probably more. Dean Hupp. How long before we have a true Martian colony, like people born and die there and never see the Earth? We have no idea. Like right now, the only Martian colony that makes sense financially is a research station equivalent to what we have down in Antarctica, where you've got nations that are spending vast amounts of money to send researchers to Antarctica to do important scientific work about, there's the ice cube observatory that's there. You've got a bunch of other telescopes. You've got people that are doing atmospheric work as well as searching for meteorites. Like, there's a lot of science that gets done in Antarctica. And there's an enormous amount of science that can be done on Mars. And it makes sense to set up a research station on Mars. You send astronauts, they go to Mars, they do this work, they come home, you have rotations of different astronauts. So that all, there's budget, there's the drive to do this. It makes sense for us to send astronauts to Mars to have a research station. But to take it to the next level and go there's a Mars colony where people go, they're born, they die, they live out their lives. There's no really good justification for doing that right now. In the same way, there's no real justification for us having a colony in Antarctica. That Antarctica is a really difficult, terrible place to live. Compared to other places on Earth. And so if you're trying to figure out a place to raise your family, if you really love snow, there's still places that are nicer to live at than Antarctica. And Mars is dramatically worse than Antarctica. And so there's got to be some kind of compelling economic reason why nations of the world, individuals would be willing to spend the kind of money that it would take to have a presence, a long-term presence on Mars. You're looking at tens of trillions of dollars over decades to be able to set up, establish, and continue to support a colony on Mars. And there's nothing that's going to pay for that, right? There's no unobtainium that you can mine out of the regolith on Mars. There's nothing to trade back to Earth. That anyone who goes to Mars is going to be done at the enormous expense of the various nations that are underwriting it. And I know that Elon Musk has said that no, humans need to go on Mars, and I'm going to set up a city on Mars that's going to have 1 million people. We'll see. How long will he be willing to bankroll that, or how long will people be willing to go to Mars and try to survive in a place that is essentially uninhabitable for human beings without an enormous amount of expense and technology. So how long is a question of when our technology will trivialize living on Mars. And so you can think of places on Earth that same conversation, you'd be like, live in Phoenix, Arizona. That's ridiculous. That place is too hot. There's no water. Nobody could ever live there. And then we get highways, we get air conditioning, we get electrical grid, we get internet, we get transportation networks, we get hydroponics, we get, all of this technology starts to build up to the point that people go, yeah, Phoenix, that sounds all right. I could live in Phoenix. The weather's really nice there. And what a place that has gone from uninhabitable for a large portion of humanity becomes a place that people can actually live. And so it's going to be our technology that trivializes living on Mars, is when a self-sustaining Mars colony will then begin. And we are nowhere near that. I mean, we've not set foot on Mars once. You saw what happened when we set foot on the moon. We set foot on the moon and then we didn't go back for 50 years because there's no economic reason to go to the moon. And Mars is even harder to get to than the moon is. So, so you'll know we're there when our technology is trivializing it. When, people build summer homes on Mars, people go there for longer periods of time. But I think we are looking at the hundreds of years. I don't think in this century we'll see a long-term presence on Mars that isn't anything beyond research. After the singularity. Bob Hoppeldorf. Would it be really cool to find out life, at least microbes, had spread all over the place via panspermia? Yeah, absolutely. If we found evidence of microbes on Mars or microbes on Europa or Enceladus, and we were able to measure them, measure their genetic, measure their genes, and we're able to determine when we had a common ancestor with those life forms, that would be really interesting because it would tell us sort of how life was able to go from world to world within the solar system. And then it opens up this idea about, could there be galactic panspermia? Could you have life going from some other star system through the void of space to reach Earth? Wouldn't it be cool if we could actually sample life on Proxima Centauri and actually realize that we share a common ancestor with life on Proxima Centauri? It would be kind of crazy that if all life that we find in the Milky Way is all related, that when you think about the fact that there could be 10,000 Oumuamuas passing through the solar system right now, and they could have organic compounds, they could have life hibernating inside of them, and that you just have this constant transfer of life from star system to star system across the entire galaxy. That's a real possibility. So yeah, it's that is interesting. And then finding life that doesn't share a common ancestor with us as well is incredibly interesting. So there's every flavor of this question is really interesting. And right now, I'm always amazed, or I sort of shiver at the thought that we exist at a time before the discovery of life in the universe, or an expanding discovery of non-life in the universe. We are, is there life in the universe? It's a scientific question. And we are decades away from being able to answer that question, and maybe a few more decades away from being able to rule out that question to a larger and larger sphere around us. And so what right now is an I don't know will turn into I know the answer. The youngest of you watching right now today will learn the answer almost certainly, almost certain with certainty, whether or not there's life in the universe, that either life has been found here in the solar system or in another, in the atmosphere of another star system, or life has failed to be found with certainty with a larger and larger sphere thanks to future space telescopes. And, this is a question that humanity is puzzled for as long as it's been able to look up into the sky and think about stars as other places in the universe. I mean, people thought about this question back in the Greek era, the Roman era, and we still don't know the answer. And yet we are now just a couple of decades away from knowing the answer, which is pretty cool. So people are asking about the timescape model. I don't have any opinion. I'm going to interview somebody. Stop propaganda. Is it true that 12 Hubble mirrors were actually ground, one facing to the stars, and the remainder pointed us for security monitoring? So not exactly. The the National Reconnaissance Office for the United States has ground monitoring, Earth observing spy satellites. And there's the Keyhole fleet. And there are, how many of them? So they've been orbiting for, about 30 years. So about the same age as the Hubble Space Telescope. And I don't know how many there are. I mean, there are probably dozens of them. And, I'm sure people who, optics people who were involved in one program were involved in the other program, and this technology went back and forth and was shared. But the telescopes that were designed to be pointed at the Earth are slightly different. They have a different focal length than the Hubble Space Telescope. Hubble Space Telescope was designed to be an astronomical observatory, while the Keyhole satellites were designed to look down at the Earth from a relatively close vantage point. And we know that about a decade ago, a little longer, the National Reconnaissance Office gave 2 mirrors to NASA. And they had 2 leftover mirrors, and they were like, "Hey, do you want these? They're not powerful enough for our needs anymore," which means that the National Reconnaissance Office now has stuff that is well beyond the capabilities of the Hubble Space Telescope, pointing down for used as spy satellites. And so NASA was able to turn one of those into the Nancy Grace Roman telescope. It's going to be launching in 2027. They haven't figured out an idea to use the second one. The idea that I like the best is to send it to Mars. Like the rule that the government gave NASA was, you can have these telescopes, but you can't point them at the Earth. So NASA was able to adapt one to be the Nancy Grace Roman. But it would be amazing if they sent the second one to Mars, and then it would just be a version of a Keyhole satellite pointing at the Earth, but it's pointing at Mars and is revealing objects on the surface of Mars. I mean, the Mars Reconnaissance Orbiter is the largest telescope that is orbiting around another planet. And it's able to see objects on the surface of Mars that are like 30 centimeters across, like about a foot, or a little bigger. And so you can just imagine, what, something the size of the Hubble Space Telescope pointing down. Like, I think Mars Reconnaissance Orbiter's mirror is like a meter, which is pretty big. So it would be much larger than that spacecraft pointing at Mars and revealing interesting features on the surface of Mars. That would be awesome. So I do hope that at some point NASA is able to come up with an idea for the second one of these incredible telescope mirrors. All right. We've reached the end of our second hour. We've reached the end of overtime. So I think I'm going to wrap things up, and I can feel myself losing my voice. But hey, thank you everybody for hanging out once again. Now, just fair warning, next week we are going to be on European time. So it's going to be 8 a.m. for me. It's going to be like 11 Pacific time, Eastern time. And it's going to be 5 o'clock for people in Europe. And that's perfect for Zapfan and John Seffel. So they'll be able to watch the show at a reasonable time. But a huge thank you to the moderators for sticking around and finding questions and putting them into the database. And thanks to everybody who asked questions. This was the most viewers we've ever had, 604, which is kind of bonkers. But I have a really good time. I hope you have a good time. And we've got the final question show for coming out tomorrow. And then we've got a whole bunch of really cool interviews coming out pretty soon. So stay tuned for all of that. All right. We'll see you all next year, everybody.